Oops. Sorry, Hiba. Okay. Uh, some students tend to ask me, Doctor, wajid qawaneen. There are too many laws, okay, and too many rules. And it is important for us to understand the difference. In the very first chapter, we introduced the idea. Okay, it is very important for us to understand the difference between a law and a rule. Okay, these two things باللغة العربية اثنيناتهم اسمهم قانون. But in English, these two actually mean two different things. Okay, and in physics, the whole point of physics, the whole point of everything, is to simplify everything into as few equations as possible. Okay, so if you actually look at just one chapter, chapter number 3, and you go through it, you will see so many equations. I mean, I think by the end of the chapter, we end up with, I mean, like 25 equations. Okay, these are not 25 laws. These are 25 rules. Okay, and we don't need to remember the rules. The reason is the rules are derived from the laws of physics. Okay, so the only 4 equations we need to remember from chapter number 3 are the 4 equations that we spoke about initially. You know, v equals u plus at, v squared equals u squared plus 2as, s equals ut plus half at squared, and I think actually 3, not even 4. Okay, there's one for average velocity if you want to count that, but that's it. Okay, every single other rule in that chapter is derived one way or another from these 3 laws. Okay, so you don't have to memorize or remember all of these. What you do need to do is, okay, what you do need to understand is understand these 3 laws and how do they interact with each other. Okay, once we understand how these 3 laws interact with each other, what happens is we can derive all the other rules in an exam, in a problem, in whatever situation we are in, from just these 3, without memorizing all of them. Okay, then we spoke about free fall, and we also spoke about finding velocity and displacement from acceleration via integration. Now, we did not do an example on free fall. I realized that. One of the reasons is I want to introduce a concept in today's chapter, motion in 2 and 3 dimensions, chapter 4, and then we will come back and I promised you do an example on free fall. And once we're about halfway through today's chapter, you will realize what the issue is. Okay, so to start with chapter 4. Okay, now in chapter 3, what we did was we looked at a very simplified version of life in which everything is one dimension, like playing Super Mario. Everything just goes left or right. Okay, actually Super Mario is more complicated. He goes up and down. For us, we're just going left and right, nothing else. Okay, so we're going to introduce today the 2nd and 3rd dimensions because, well, our normal life is in 3D. Okay, but the good news is, so that's the bad news part. The good news is we're not actually going to learn much of a new thing because, as you will see, everything we do in 2 and 3 dimensions is exactly what we did in 1 dimension, but we are simply extrapolating. We are extending the regime of the laws to 3 dimensions. And even then, you will see, will not actually make the problems more difficult, or it will not make life more difficult. There is a very easy way to do it. Okay, so let's start. I'm guessing everyone can see my screen. I am going to get the chat as usual on my phone screen so that I can see what you're writing as we're doing it. Okay, I'm able to see it. Okay. So here we go. Oh, some of you have spoken to me about lectures not showing up on YouTube as soon as we are done. The reason is because I'm not actually doing this via YouTube. I'm doing this via Google Meet on SQ servers. So what happens is once we're done with the lectures, I need to download these lectures, upload them again to YouTube. And as most of these lectures recordings are 1 to 2 GB, that takes a lot of time. Okay, and then YouTube has to process it. So it usually takes me at least 1 day to be able to process it, sometimes 2. Okay, so here we go. Motion in 2 and 3 dimensions. First thing first, everything we did so far still applies. Okay, we're not going to cancel anything we have done so far. Now, what did we do? We spoke about position. We spoke about displacement. We spoke about velocity, about acceleration. We spoke about equations of motion in 1 dimension. All of these, first, we're going to redefine them just to incorporate 2 extra dimensions. Okay, and it's not as difficult as it sounds. So this is just a point in space. Okay, the green dot. And I'm going to draw a 3-dimensional Cartesian coordinate system, x, y, z. So far, so good. You've all seen this before at one point or another in your life. Now, what happens is, when I come to describe where this point is, and this is, again, something that you have already done, okay, first, forget the 3rd dimension. Let's just speak x, y. If I have something like this, x, y, and I have a point here, at some point in life at school, you already know that to describe this point, you give it an xy number, something like, for example, 3, 2. Okay. This 3, 2 are its position on the x-axis and its position on the y-axis. And we can do the exact same thing with a 3-dimensional object, only we'll have 3 numbers, x, y, z. 1 number to describe how far is it from the 0 of x, 1 number to describe how far is it from the 0 of y, and 1 number to describe how far is it from the 0 of z. So far, so good. How do we find these? We'll come back to it later, but again, you have done parts of it already. Okay? So, instead of just giving the position as some number, now we're going to give it a vector that includes x, y, and z. And the I and j and k coordinate systems, unit vectors. So far, so good. You're seeing we are bringing what we did in chapters 2 and 3 together. Chapter 2 all about vectors, chapter 3 all about just 1 dimension, and now we're bringing them together. Okay, and we call this the position vector, R. And it includes everything you need to locate a particle in space. What it does is it extends from a reference point, usually the origin, so 0, 0, 0, to wherever our particle, wherever our body, wherever our object is. So far, so good? No problem so far, I hope. Let's do an example. We have something at position vector -3, 2, 5, all in meters. Sohaib, is that no problem, or no, we have a problem? Okay, let's do the example. Maybe it will become clearer if that is no, there is a problem. So this is our position vector. Oh, perfect. Okay, so this is our position vector, R, xi, yj, zk. I'm just going to substitute the numbers in. We get -3i plus 2j plus 5k. So far, so good. No issues. To locate the particle, this is how far it is parallel to the z-axis. This is how far it is parallel to the y-axis. This is how far it is parallel to the x-axis. Simple. We have done this a million times before in the vectors chapter. In our tutorial, we did some examples. In school, you did a lot of these. Nothing new. Let's go to displacement, the other concept we introduced. Well, If we're going from, if the particle is going from one place to another place, it is going from some place R1, which is described by R1, to some place described by R2. How do we know the difference between the two? The distance between the two? Well, usually what we did is, with just one axis, is this number minus this number. And this is exactly what we do here, but in 3 dimensions. And we have already done this in the vectors chapter. How do I find this distance? How do I find this distance? You remember what we did in chapter 2? Well, I have R1, I have R2. My distance between them is simply the change in the position vector. R2 minus R1. We find the vector between them. Okay? How do we do it? We can do it using the graphical method, which I don't like, or we can just doing it using the components, which is rather easy. So, very, very simple. Everything we did in X. So basically what we did in chapter number 3 was just this bit. Now we are adding this bit and this bit. Okay? Speak about something else we spoke about in the previous chapter. Average velocity, instantaneous velocity. And most of you will start to find this boring by now because, okay, we have seen this before, we have done this before. Just carry on with it. Average velocity was delta x over delta t. It now becomes delta r over delta t. Very simple. We just took x and we put in x, y, and z. R. But you will notice that we do the calculation for x alone, y alone, and z alone. This is what we did before. This is the new bits. But it's the exact same thing. We're just repeating it 3 times now, one time in each axis.
Doctor, give us an example.
Right, coming up. An eagle flies 300 meters west from a mountain. Remember, never eat silly worms. Okay. An eagle flies 300 meters west from a mountain in 20 seconds. It sees a mouse below on the ground and dives vertically down 400 meters for 5 seconds to catch the mouse. Find the eagle's average velocity for the 25-second interval. And we have 4 options. Okay, so here's my eagle, goes 300 meters west in 20 seconds. As I said, whenever we have a problem, the easiest way to solve it, we said this in chapter 1, is to draw the problem, write down everything we have, write down what we want to find, and then actually find it. Okay, it sees a mouse below on the ground and dives vertically down for 400 meters. And it does that only in 5 seconds. Find the eagle's average velocity for the 25-second interval. Now, total is 20 plus 5 times 25, that's fine. Now, this is very important. Some of you might not have noticed it. We said average velocity. What's the difference between find the average speed and the average velocity?
Velocity with magnitude, with direction.
Excellent. But there's one more difference, which is key. So how do we do this problem? Do we do 300 divided by 20 plus 400 divided by 5? Or do we do 400 plus 300, that is 700 meters? Okay, I'll try. Do we do 400 plus 300? So here's one option. I'll write it down and you can tell me if it's right or wrong. We want to find the average velocity. I do the total distance divided by the total time, and I get 700 divided by 25, which is 28 meters per second. Is this right? Okay, one person said wrong. Why? No. Find the resultant first. No, no, wrong. Okay.
Because it's not
It's
in the same direction.
Okay, it's not
could
the
be
same.
find the compound of
So we can.
x-axis and y-axis.
Okay, both of you are correct. And Abdul Hakim لخص السالفة. This is velocity. Remember the difference between velocity and speed. Speed was distance over time. But velocity is not distance. What is velocity? It is displacement over time. The distance here is 700 meters, but displacement is not. Displacement is the resultant vector from this point to this point, right? So first, we need to find what is the resultant vector. Okay, so the resultant vector's magnitude would be, the easiest way to find it here is using Pythagoras. Excellent. So 300 squared plus 400 squared is 250,000. And then if I square root this, I will get 500 meters. Yeah, 500 meters in the total amount of time, 25 seconds. So my actual, this is wrong. This is speed. For velocity, it will be 500 divided by 25, which is equal to only 20 meters per second. Okay. Now, here it's easy because the only one that has 20 is this one. Okay, so we know it's A. But remember, this answer is not complete. We need the angle. How do we find the angle? Well,
tan theta.
perfect. Tan theta. We do tan inverse of 400 over 300, and we get 53 degrees at 53 degrees below horizontal. Okay, so we just did a practical example of how to find the average velocity from displacement in 2 dimensions. Okay, so we just went up from 1 dimension to 2 dimensions. Okay. So instantaneous velocity, velocity of a particle at a single point in time. We've said that already before. The limit of average velocity as the time interval shrinks to 0 is the definition of instantaneous velocity. So if we go from position R1 to position R2, what is going on here? I'll see this later. Okay, my difference, okay, if I want to find my velocity, is dr over dt. Okay, differentiation. Okay, the direction of the instantaneous velocity of a particle is always tangential to the particle's path. Okay, again, this is not something new. These are just definitions, extra words to things that we have already done. We already know these things. Okay, only before we did dx over dt, now we do dr over dt. Same thing, more dimensions. In unit vector form, we write d by dt of x plus y plus z. And we end with this, dx by dt, dy by dt, dz by dt. Again, each one is a separate thing. We did this already before. These are the new bits. I have promised to upload something to do with the differentiation, and I have not forgotten. So I have actually made it. I will upload this today. Okay, some basic differentiation. How does it work? Okay. So what this gives us is, this is an interesting bit. It might not look interesting, but it will work out in a bit. Okay, that Vx, Vy, Vz. So we have 3 different velocities in 3 different directions. Okay, which is very interesting because rather than giving one velocity in that works in all directions, we are saying there are 3 different velocities for 3 different directions, which, if you think about it, means our calculations would be way, way easier, okay, because I can do each calculation on its own without complications. I can do Vx alone, Vy alone, Vz alone. Okay, so Vx will be dx over dt, Vy will be dy over dt, and Vz will be dz over dt. Which also means that if my motion is only in 2 out of 3 directions or 1 out of 3 directions, I don't need to do anything in the other directions. I can just stick to 1. Examples will follow. It will hopefully make these clear. Okay. I'll try to slow down as much as possible, but I am really hoping that you are going through the sections that we're covering in each lecture in the book before the lecture, because this is a really, really big course, okay? And going at this speed is the only way, give or take, to finish it. This is why it's very, very important to go through the material beforehand, so that when I am explaining it, this is not the first time you are looking at the concept. Okay, but I will try to slow down as much as possible. The problem is, if we're late in the syllabus, then we will have to speed up in the later chapters, and the later chapters are more complicated than the first chapters. But I'll do my best. Okay, we already have one issue where canceling last week's lecture meant that we are late by 1 lecture. Well, I'm not speeding up any more than normal, but I'll try to slow down. Okay. Now here's an important point. A velocity vector does not extend from one point to another. It only shows direction and magnitude. So on an XY axis, if I am saying I start here and I end up here, and I draw this, what does this arrow tell me? Yeah, what does this arrow tell me? Anyone?
Maybe direction.
Okay. Change in position, direction, displacement. Now the answer is, this is a mathematical concept. It's a vector, right? So what it actually tells me really depends on what is it that it is telling me. Now, I know that sounds really stupid. I just said the same thing twice in a row. Okay. I need to define, in the first place, what is this vector? Am I talking about position? Am I talking about velocity? Am I talking about acceleration? What am I talking about? Now, if I was talking about displacement, then, or if I was talking about position, okay, what is xy? Xy, exactly. Exactly. What is xy? If my x, for example, is time and this is position, for example, then this arrow tells me 3 things. It tells me the magnitude of the vector, it tells me the direction of the vector, and it actually extends from one point to another. It literally tells me it's going from this point to this point. But if this is velocity, then it only tells me 2 things. It tells me what is the magnitude, so how fast am I going, and what is the direction. This, if this vector is velocity, it does not say I am going from here all the way to here. No, it just tells me this, how long it is, gives me an idea, of how big it is. That's it. Okay. So it only tells me that at this instant in time, this is the magnitude and these are the directions. It's not actually telling me what the path is. Let's take a look. The x and y coordinates of a particle as a function of time are x of t equals d plus ct and y of t equals d minus et. B, C, D, E are all constants that are positive. Okay. Which arrow could be the velocity of the particle? A, B, C, D, or is it just 0? Take a minute, try to do it. Okay, one person says D. Okay, so most of you say D, which is correct, because velocity is the differentiation of the position. If I differentiate x of t, it will give me v of t is equal to simply c and vx of t, and vy of t will be minus e. So my x is positive, so it's going to be in this direction, and my y is negative, so in this direction. So my resultant is going to be somewhere in this direction, which matches D. I'm really happy that most of you managed to do this. Okay. Average acceleration and instantaneous acceleration. Mariam, Keith. Well, we differentiated, right? We differentiated x. B is a constant, so it goes to 0. T goes away because t to the 1. 1 minus 1 is 0. So t to the 0 is just 1. We just end up here with c. And here, the same idea, but we end up with minus e, which means that my velocity vector in the xy axis is my v is equal to vx, vy. My vx is positive, my vy is negative. So it has to be going in this direction. The resultant has to be going in that direction, because there is no t beside it. If you are differentiating a constant, then it's just 0. Yeah. Remember, the rule for d by dt of t to the power x is equal to xt x minus 1. Yes, exactly. Okay, average acceleration and instantaneous acceleration, and this is wrong. This should be saying 4-2. Average acceleration, v2 minus v1 over t. So delta v over delta t. Since our velocity now is a vector, my acceleration is also it is 3-dimensional vector. My acceleration is also going to become a three-dimensional vector. Instantaneous acceleration, again, dv by dt, same as in the previous chapter, nothing new here. Okay, let's do another example. Instantaneous velocity of a particle clockwise quadrant. So this might be better. Okay, the figure shows a circular path taken by a particle. If the instantaneous velocity of the particle at that one moment, at that instant, is v equals 2i minus 2j, through which quadrant is the particle moving at that instant if it is traveling clockwise? So, oops. If it's going clockwise, so if it's going in this direction, and we know that v equals 2i minus 2j, where is it? Is it first quadrant, second quadrant, third quadrant, or fourth quadrant? Three or four, 1, 2, 3, 4, 3, 222. Okay, so we're all over the place. Let's draw it. Let's draw it. Which direction is 2i going in? 2i is this, right? What about minus 2j? The minus is important. Correct? What is the resultant of these two going to be? In this direction, right? Okay. So we need a velocity which is going in this direction. Now we said the acceleration, sorry, we said the velocity is the differentiation of the position, also known as the gradient, tangential line. Acceleration is the differentiation of velocity, so it follows the exact same rule. Okay.
دكتور
Yes.
الكوادرات لما يكونوا إنه 1 2 3 4 ما كذا.
Opposite.
أيوة يعني 1 واللي جنبها 2 واللي
هذه 2.
تحتها 4.
أيوة دكتور عاكس.
الطريقة. Okay, my bad.
أيوة.
My bad. So it should be going 1 2 بهالطريقة.
Yes.
Yes
Okay,
دكتور.
sorry. My bad. My bad. Okay, so most of you were saying 3 and 4. Let me draw the tangents. This is one tangent. It looks the same as what I want. I will try another one. 4 is going to be in this direction. 3 will be in this direction. And 2 will be in this direction. Which one looks like this one? First quadrant. Yeah? Clear? Excellent. So we said acceleration is equal to dv over dt, right? And we said velocity is equal to dr by dt. So far, so good. I'm sorry, I'm not allowed to do it in Arabic. Also, I really don't know how to do it in Arabic. I have studied physics and English. Sorry. Okay, let's do something. Let's delete all of this. How do I delete all of this? Screen. No. I want to. How do I delete this? There we go. Let's start over. It said the particle is moving clockwise. It's moving this way. Okay, this is position. Velocity is tangential, or otherwise known as the gradient at any given point. Yeah. Okay. So this xy is giving us the position. We want the velocity. What do? We differentiate. We find the gradient. The gradient in the first part in the first quadrant is going to be parallel, like this, tangent. And since this particle is moving in this direction, it will be in this direction, right? Now, if I draw the gradients in all 4 quadrants, I will get this. Now, only one of these, okay, actually corresponds to this. Since we have 2i minus 2j, this is 2i, this is minus 2j, my resultant is going to be somewhere in this direction. Now, the only one of these 4 tangents that looks exactly like this is this one. That corresponds to the first quadrant.
زين دكتور لو كان السؤال anti clockwise وش بيكون الجواب؟
لو كان anti clockwise?
أيوه.
Okay, let's do anti clockwise. Now it's going this way. صح؟ مقلوب. The velocity is still 2i minus 2j. So my velocity is still in this direction, صح? Only now my arrows are in the opposite direction. صح? So which one is it? 1, 2, 3, 4. It's going to be in 3. No, I actually changed the question.
دكتور يعني طريقة التانجنت لاين أو الفالر الثابتة في الكلوك والأنتي كلوك؟
لا. Take a look. أول سؤال كان شوفي أنا مسحت الأنتي هنا ف clockwise. I think وعد was it? Okay. This is clockwise. الحين سؤال ثاني counter clockwise.
زين وكيف نرسمهم على أي أساس؟
Clockwise, counterclockwise. Yeah. Okay. Muhammad al-Yahyai. This problem is only in XY, not in XYZ. So if we change it to X to the J to K, we'll do the same thing, but instead of XY, we'll write XZ. Okay. I don't know who was talking to me. I don't actually see who is it that is talking to me. So what's the difference? Ryan. Okay. So if we're going clockwise, so this is clockwise, this is counterclockwise. We draw a tangent, صح? This is my tangent. Now my direction is always going to be in the direction of motion, صح؟ إذا أنا أتحرك هذا الاتجاه, my velocity بيكون في هذا الاتجاه, ما في هذاك الاتجاه. صحيح?
صحيح.
Okay, so this is my tangent, and this is my direction because it's with the direction of motion. On the other hand, if I choose the exact same point, but when going counterclockwise, my tangent is going to be the exact same magnitude, but the direction will be opposite, because now it's going in this direction. Okay, so if I draw all four, you will see the directions معكوسين مقلوبين.
Okay, I got it. Thank you.
Okay, Mariam, we did not do this in chapter 2. Okay, so this is not a property of a vector, but a property of, okay, it can also be a property of a vector, but it is all in the question, or it is all in the problem being solved. Okay, so the only way to distinguish is to look at the direction of motion. Okay, so okay, so acceleration dv by dt, and we end up with 3 different velocities. AX, AY, AZ, just, sorry, 3 different accelerations. Just like for velocities, we ended up with 3 different velocities. Okay, so we will have X, Y, Z, Vx, Vy, Vz, Ax, Ay, Az. Okay? We have done this in chapter 3. These are new. How do we get the components of acceleration? We differentiate the components of velocity with respect to time. And just like with velocity, it tells us the direction and the magnitude. So this time we're looking at acceleration. Careful, it looks the same, but it's a bit different. Okay, so the x and y coordinates of a particle are again given by the same function, d plus ct, and d minus et. What is the acceleration? Excellent. All of you are correct. The correct answer is E. It is 0, because we differentiate to get acceleration from position. We differentiate 2 times. X of t equals b plus ct. The first differential is becoming just c, and the second differential, since c is a constant, is going to be 0. And that's the exact same thing with y of t. Okay? Good. Most of you got this right. Actually, every single person got this right. Excellent. Okay. So we finished 4.1 and 4.2. If we go to 4.3, projectile motion. So now what happens when we actually take all of these ideas and put it into an actual problem? Okay. So how many of you played this game? Angry Birds. It was really big some time ago. Okay, I remember I was addicted to the original version. The new version is really, really horrible. They want you just to pay money and get add-ons. I hate it. But I'm pretty sure every single one of us, including myself, played this game at some point. And it was an amazing testament of how a very simple physics equation can turn into a game. Okay, so this was the idea of the game, simply. Nashaba, you pull it in some direction, and depending on the angle and how much you pull it, it would give you something. Well, if you did it really badly, it would go, or it would go something like this, or it would go something like this, or something like this. Or if you do it too high, then it would go all the way and then just, pointless. It wouldn't hit anything. Okay. And today, we're going to analyze what is the calculation that goes into this game, or what decides what the trajectory is of motion. Okay. Now, we spoke about the 4 kinematic equations which describe an object's motion. Yes. Yes, Sultan. Yes. Exactly. Projectiles. Maqduvat. Okay. So, we described we spoke about 4 kinematic equations which describe an object's motion. Okay, I'm trying to find them here because there's no space on this slide to write them. These. Okay, these 4 equations. يا أخي في الرياضي جالس يقفز. Okay, now, as we said, and as we saw in the video, okay, in the previous lecture, if there is no air resistance, then all objects, no matter how heavy they are, or how big they are, will fall at the exact same acceleration, which is 9 point. Again, I'm having problems here. This is supposed to be 9.81 in this book. Okay, 9.81 meters per second, or as we wrote it, meters per second squared. Okay. Now here's the key point about gravity. Remember, I told you why by the end of this lecture we will why by the end of this lecture we will go back to doing the example of the free fall. This is the reason. G is the gravitational acceleration, 9.81 meters per second squared. Where does it act? In which direction? It always acts vertically towards Earth. And our friendly neighborhood Spidey is going to help us with this. Okay, if we're standing up, gravity is downwards. If at an angle, gravity is still downwards. If it's upside down, gravity is still downwards. This way, still vertically downwards. Attached to a wall, still vertically downwards. And as silly as this Spider-Man thing looks, it is actually demonstrating a very important point that most students end up forgetting at one point or another during this course and future courses. It is that gravity acts always vertically downwards at all times, okay? Many students end up at some point making a mistake and drawing gravity like this. No. Okay. This is wrong. Okay. Gravity is always pointing downwards no matter what. So let's consider something moving, okay? Let's consider a ball that is falling down. Falling down. It starts from rest. Its velocity is 0. And it ends up at some velocity Vy. We use our normal equation. Vy, well, V equals U plus AT. Okay. Let me write it down exactly as we do. Like this. Okay. So the only thing different now, well, not different, we're just actually substituting a number. What is my acceleration when I'm going downwards? It is simply gravity. And I wrote it here, G equals minus 9.8, because this slide is actually really bothering me now. If I do 9.81, then there we go. I'm going to have to go through all of these slides and change it, aren't I? Okay, I'll do that later. Okay. So if I put in the numbers, my initial velocity is equal to 0. My A is minus 9.81. So what is my equation of motion going to be? Minus 9.81 T. Remember, beginning of this lecture, I told you rule and law. Law, rule. We don't need to remember all the rules. This is what I told you, remember? Just by knowing this law, we derive the rule, and we can do this every single time. Okay, so do not remember this. Do not memorize this. Okay? Okay. Some students sometimes ask me, why did you decide minus 9.81? Why not just 9.81 without the minus? The answer is because I chose so. Okay, I'm not being snide or snarky about this. This is literally the reason. I have a question. Why do we call this up? Why is this direction up? Can you give me any answer for that? Why am I calling this direction up? Why am I not calling this down and this up? Anyone? No? Okay, what if I decide to call this direction smiley face and downward direction sad face? Is it a problem? It's not a problem. Yeah? It is simply, we simply call up because someone at some point in history decided to call it up. Okay? Now in physics actually really doesn't care, okay, what I call it, as long as I obey one very important rule. Once I call it something, I have to stick to that rule no matter what in that problem. Okay, I cannot change my mind in between. Okay, so in this problem, I have chosen that going up is positive and going down is negative. I chose to label it as such. Okay, so when the ball is going downwards, okay, I said minus G, because I have decided from before that down is minus. Okay, what if for some reason whatsoever, and we will do examples of these later, I decide to call up minus and down plus? كيفي؟ قمت من النوم راسي ضارب ما شربت جايزين اليوم مخي ما سيده. This is plus, this is minus. My ball is still going downwards this way. What is my acceleration then? No one's writing. minus v then. So most of you are getting it right. It's going to be plus g. The only reason it is minus here is because I have defined this to be minus. It's plus here is because I have defined this to be plus. Okay? It really depends on the problem. There is no right or wrong way. Okay, both are equally valid. The only rule is stick to it. Okay? Now here's another question. What about the x component? So we were talking about the y component. What about the x component? Are there any forces in the x direction? Is there anything doing it? We're neglecting air resistance for the time being. If I say my acceleration is in this direction, 0, because there's no gravity downwards. Remember, we said gravity is only down. Okay? One of the rules, one of the lovely rules, this is why I told you it's very nice that, you know, we have Vx, Vy, Vz alone, Ax, Ay, Az alone, is because in an orthonormal system, okay, the three directions are upset with each other. They never speak. Okay, زعلانين متخاصمين. They never speak. Okay, so whatever happens in one of the axes doesn't do anything to the rest of the axes. The only time this is different is if I have something in between two axes, then I do projection, x projection, y projection, or z projection, y projection. Okay, otherwise they don't speak if it's exactly on the axis. So gravity doesn't actually affect this thing in the y and the x-axis. So if I am looking at these two separately, okay, what I will get is I have an acceleration downwards. So this distance, sorry, so this distance is bigger than this distance, is bigger than this distance because my velocity is increasing. Yes? But since my acceleration, so ay is equal to minus g, ax is equal to 0. Since my acceleration in x is equal to 0, my velocity is constant, it's not changing. So if you notice, this distance does not change whatsoever. Yeah? So let's draw the resultant every single time. Okay? This is my resultant here and here, it's here. Then here. If I'm drawing the vectors, okay, my x vector is the same every single time, but my y vector is for velocity, my y velocity is becoming bigger and bigger and bigger because there's gravitational acceleration. Okay. And the result is, the resultant, since y is becoming bigger and bigger, my resultant is going to become slightly more and more and more towards the y-axis. Now, if I join these red lines together, what do I get? If I join these lines together, I get a curve. Yeah? This is what I get. I get a curve. Which is why here you ended up going eventually downwards, which is why whenever you throw something, it goes like this. Okay, let's take a look. Yes. Noor, Saud, Ayham, Sultan, they're all correct. Okay? It really depends. Okay? All right. Let's do an example. Or let's do a PIQ to understand it, to see if we have understood what I have blabbed on so far. A package is dropped from an airplane flying east at a constant speed, v plane. What are the components of the initial velocity of the package? V naught x and V naught y. Ignore air friction. What are the components of the initial velocity the moment it leaves the plane? And it's dropped, not thrown. Bear that in mind. Okay, A. B. What if I told you, oh, interesting, B, C. What if I told you the correct answer is C? Now, the plane, now I'm going to draw a very ridiculous looking plane. Okay, you will be very happy to know that I don't do Oman Air's livery. Okay, the plane is already going at V plane. And its Vy is equal to 0 since it's going straight. Yes, it's not going down or up. Now, when I just leave the package, while I am inside the plane, everything is inside the plane. The package is inside the plane. Anything inside the plane is also moving with the plane, right? So it already has a velocity, Vp. So what happens is, as soon as it leaves the plane, that velocity Vp that it had while inside the plane doesn't actually disappear. Okay, it's still there. So it still has a velocity in x, which is Vp, but its Vy is equal to 0. Now what happens is, over time, Vp stays constant, but Vy increases because of gravity. Okay, so let's try again. Package A is dropped from a plane moving east at a constant velocity. So we have a plane, it's going east, V plane, constant velocity. Package A is dropped from this. At the same time, from the same height, okay, package B is dropped from rest from a stationary, not moving helicopter. So helicopter is not moving and it's dropping package B. Okay, ignoring air friction, which is correct? A and B reach ground at the same time, but B has a greater vertical velocity. A and B reach ground at the same time, they have the same vertical velocity. A reaches ground first, B reaches ground first, or B reaches ground first because it falls straight down and A has to travel much further than B. Now, what I can tell you is this package B is going to fall like this. This one, since it has an X component as well, will fall like this. A, B, E, C, D. Okay. What if I told you to remember that X and Y are upset? They never speak with each other. Remember this. X and Y are upset. They don't speak. And A and B are the exact same package. Okay. So the correct answer is C. No, sorry. No. Undo. Bad. How do I undo this? Oh, okay. Here we go. Thank you. The correct answer is B. Sorry, I read it too quickly. Okay, B. They reach the ground at the same time because they have the same mass. We are neglecting resistance, but even if we take resistance into consideration, they have the same mass. They are both going down at 9.81 meters per second square of acceleration. They are released at the same time and from the same height. So vertically, their velocities are going to be the exact same time. Okay? A has an initial velocity in the x direction. So while B is going to drop like this was going to be like this. Okay? So if we are assuming that they have صندوق الأول ما تحرك قبل at the same time and from the same height. Okay? They're going the same y distance. X and y don't speak to each other no matter what. Okay? So the fact that this is the amazing bit, okay? The fact that A has a horizontal velocity makes no difference. It only makes difference in how far it goes in the x-axis. It affects nothing in the y direction. So they will actually hit the ground at the exact same time with the exact same velocity in the y-axis. See, it's a very important thing. Same vertical velocity. I'm going to underline it 4 times. Okay. If I said they have the same velocity, that would be wrong. Okay. So there's a big difference. Okay. I understand what Noor is saying. Okay. Noor, I'm not saying they have the same velocity. I'm saying they have the same vertical velocity. The y component is the same, not the total. Because what happens at the end when we reach? Okay, when we reach, okay, B will have Vy equals, let me say just some number, 100, for example. Okay. A will have Vy equals 100, but also Vx equals V plane, right? This is what you mean, okay? So they don't have the same velocity. They have the same vertical velocity. So their y components are the same, okay? Their total velocity is not the same. The total velocity of A is going to be in this direction, VA total, which is going to be V plane squared plus Vy squared, all square rooted. Okay? So this is very important. They don't have the same velocity. They have the same vertical velocity. Their y components are the same. Their total velocity is not. But what actually matters for how long it takes to hit the ground is the y. Okay? So that's why they hit the ground at the exact time. What time is it? It is 1:23, so...
دكتور.
Yes?
بخصوص الجاذبية الحين
أيوة.
لما نقول مثلا دروب، يعني الشيء يطيح من الأعلى إلى الأسفل، تكون الجاذبية بالموجب.
Say that again.
يعني مثلا نقول دروب، يعني الشيء يطيح من الأعلى إلى الأسفل. هنا الجاذبية تكون بالموجب، صح؟
هل أنت عرفت الجاذبية أنه تحت هو موجب؟
يعني رايحة للأسفل.
إذا أنت تحللها، إذا أنت تعرفها. Give me a second. Can you still see my screen?
أيوة، يعني اشرح لي هذه الثنتين، لما يقول لك دروب ولما يقول لك ثرو، يعني رايحة للأسفل ونوها للأعلى ونوها للأسفل.
ما تفرق. Whether you throw or you drop doesn't make a difference whether your G is positive or G is negative. The only thing that differs, okay, is is your definition. Let me just check one thing. Give me a second. I want to check something before I say this. Okay, so we will do this we will do part of this in the next lecture, but let me ask you something.
Yes.
I live here in Qaram.
Yeah.
Okay. SQ is all the way here. Matrah is all the way here. Okay. Now, if I say this is positive and this is negative, okay.
Okay.
Matrah is at plus 15 kilometers from Qaram, and SQU is at minus 43 kilometers from Qaram. So far, so good?
Yeah.
Okay. But if I say, no, this is minus and this is plus, because there is no reason, ما في سبب جذري، زين ما في قانون يقول انه مطرح لازم تكون صوب مطرح positive وصوب SQ negative، صح؟ انا من مطرح مطرح is going to be positive. اوكي يمكن حد ما يحب مطرح is going to say no صوب مطرح negative. Okay. In that case, okay, in that case, Matrah is minus 15 kilometers and SQ is going to be plus 43 kilometers away. Yeah. Now, what is the, now here is the question, okay? What is the distance between SQ and Matrah?
Yes, what?
The distance from SQU to Matrah is going to be, now it's minus 43 in this direction, صح? So in this direction, what is it going to be? Minus 43, صح?
Yes.
Yes. So minus
1 minute.
minus 43 plus 15 is equal to
minus
50.
58 والله كذا
58 صح؟
بالماينس.
اوكي خلينا نسويها مرة ثانية يوم الماينس والبلس معكوسين. تو هي بلس 43 في هذا الصوب، يعني في هذا الصوب صارت كم؟
موجب 43.
واحنا رايحين هالصوب موجب، فلما نرجع يكون اي صوب؟
لما نرجع بالسالب.
بالسالب. So minus plus 43 minus 15 is equal to minus 58. الرقم نفسه, the only thing difference is we have a minus here and we don't have a minus here just because of the direction. So the actual distance between them is what?
يعني السالب بس فقط للدايركشن ما قيمة.
بالضبط فقط للدايركشن وليس قيمة. فنحن عندنا القيمة انزين. So what is the magnitude here? Magnitude of 58 is 58. Magnitude of minus 58 is still 58.
Yes, okay.
Okay, so it's the same thing with gravitational acceleration. The number is always equal to 9.81 meters per second squared. Whether it is minus or plus really depends on the where you decide plus is and minus is. Okay. Yes. It really makes no difference, and we will do examples later on to make this very clear.
Okay, thank you, Doctor.
Okay. Yes, Muhammad, this makes a difference. V0, if we said throw or drop, this makes a very, very big difference. If we say, let me stop this. If we say throw, sorry, if we say drop, it means we just leave it like this. So initially it's at 0. The first velocity is 0. But if we say drop, if that's drop. If we say throw, that is very, very different. If I say throw, then oh, what's just happened here? Okay, 1 second. Okay, yeah. So Muhammad, drop, your initial velocity is 0, but if you are throwing, then you are giving it an initial velocity. Okay, so this V0 drop, this is very different because I threw it downwards, I give it an initial velocity. So V initial in Y direction is not 0. Okay, Saud, exactly. Nabhan, why don't we imagine that the movement is in the coordinate and the origin is the starting point? We can, we very much can, and this is exactly what we are going to do in the next lecture in 4.5, relative motion in 1 and 2 dimensions. This is exactly what we're going to be doing then. Okay, any other questions? The lecture is over, by the way.
Yes, sir, I have.
Okay, doctor, thank you.
No worries. السؤال اللي قبل مال الطيارة. أيوة.
When we will get the opportunity to solve the quiz which related to previous chapters.
I will release it on Thursday, inshallah. So tomorrow. Okay. السؤال اللي قبل مال الطيارة. Oh, not this slide. These slides. هذا. Noor, this one.
مستر لو الجسم اللي كان في الطائرة اللي تتحرك ما ياخذ سرعة الطائرة هي اللي تتحرك ما ياخذ سرعتها.
Can you say that again?
الجسم اللي كان في الطائرة اللي تتحرك ما ياخذ سرعة الطائرة هي نفسها، سواء كان رايح يمين شمال فوق تحت، تكون سرعته نفس سرعة الطائرة اللي تتحرك.
ياخذ.
أيوة، والطائرة الهليكوبتر اللي واقفة اللي رمت الجسم تكون ما إلى سرعة، صح؟
صحيح.
إنزين، لو الجسم اللي في الطائرة اللي كانت تتحرك بيوصل قبل
ليش يوصل قبل؟
الطائرة، لأنه في سرعة أوريدي، يعني في سرعة الطائرة اللي كان الجسم عليها.
ولكن الطائرة كانت تروح horizontally like this، ما فيها واي. ايوه، لو الطياره جالسه تنزل تحت او جالسه تصعد فوق ممكن، لكن الطياره كانت تمشي فقط بهذه الطريقه horizontally، يعني سرعه الطياره فقط في الاكس، ما عندها سرعه في الواي.
كيف ما عندها سرعه في الواي؟ ما السرعه اللي فيها اصليا يعني هي السرعه ما تاخذ يمين شمال فوق تحت، او انه الاكس وحدها سرعه والواي وحدها سرعه، كيف كذا؟
Let's draw it will become easier. الحين هذه هي الطياره، صح؟ وين جالسه تطير؟ يمين يمين يسار فوق تحت؟
يمين.
اوكي، فالطياره جالسه تروح هنا يمين، صح؟ ففي عندها هنا Vx equals رقم معين، صحيح؟
ايوه صح.
اوكي، هل الطياره تروح ريوس؟
ما تروح، لا.
ما تروح ريوس، معناته V في دايركشن مال ماينس اكس يساوي 0، صحيح؟
ليش؟ زين ترى الجسم هو يعني خلاص عنده سرعة.
إذا السرعة في هذا الاتجاه، صح؟ Remember this is velocity not speed. There's a very big difference. Speed is just one number for the entire body going everywhere. Okay, but velocity is a vector, it's directional. So you actually have 4 velocities here, okay? You have V in the x direction, you have V in the minus x direction, you have V in the plus y direction, and you have V in the minus y direction. And each one of these is separate to the others. Okay, so you are absolutely correct. The plane has a velocity. It's Vx, it's a number. And yes, Ma'ad, anyone who wants to leave can leave. The lecture is over, yeah? This is just a Q&A session. Okay, so this Vx is only in one direction. It doesn't affect the other directions. Okay, remember when we said that vectors have a number and a direction? The direction actually makes a very, very big difference. Okay, so if let me give you a better example. قلم أنا بعقل هذا الصوت. Its velocity is in this direction. In this direction, it's 0. In this direction, it's 0. In this direction, it's 0. It's only going in that direction. صح? It's the exact same thing in the plane. The velocity only applies in the direction of motion. Okay, now let's do another example. Say now the plane, instead of just being cruising altitude, it's near to an airport, وجالسة تنزل. Okay, هبوط. It means that the direction of the plane will be something like this, صح? صحيح? Are you here?
يعني دكتور الجسم مكتسب سرعة في الاتجاه الهوريزونتال فقط.
صحيح، السؤال الأول كان فقط في الهوريزونتال. الحين نجي إلى مثال آخر. Say it's going down. Okay, at an angle. Okay, it's okay. In this case, it will have a velocity Vx, some number, and it will have a velocity Vy, also some number, not necessarily the same number, but some number. Okay. In these directions, it is still going to be 0. Okay. So this is not speed, this is velocity. The direction is very, very important here.
Doctor, please upload the slides because you don't upload it for the last session.
Which one did I not upload? The Monday lecture?
Yeah.
Yeah, I'll upload them today, inshallah.
Thank you.
دكتور.
Yeah.
احنا في هذاك السؤال مال الطائرة قلنا انهم وصلوا في نفس الوقت ما بسبب انه يعني انه لانه في السؤال قالوا ignore the air يعني مثل نتجاهل قوة الرياح الهواء فما بهذا السبب قلنا انه يعني وصلوا في نفس الوقت.
حتى لو كان في سرعة هواء طالما انه two packages are the exact same thing مقاومة الهواء عليهم بتكون the same.
طيب هم يعني السرعة مالهم ما مختلفة؟
أي سرعة؟
سرعة
لكن
طيب يعني المفروض واحد يوصل قبل لأن السرعة مختلفة.
velocity in the y direction. Okay. إيش هي السرعة نفسها؟ السرعة المتجهة مختلفة. The velocity is different. The velocity is the same. Vy, both of them are the exact same thing. Let's do it something. Yeah. Let's do something. 1 second. Let's do it in a different way. Do we agree that this is the equation we're using? I need interaction. I cannot do this on my own.
Yes.
Okay. We agree on this so far. Do we agree that A equals minus G?
Okay.
Okay. So do we agree that my actual equation will be U minus GT?
Yes, but why the acceleration is negative?
Because I have defined down to be negative. I can do it positive. Do you want me to do it positive?
يعني على أي أساس نسوي بوزيتيف ولا نيجاتيف؟
انت اختاري تحت بوزيتيف ولا تحت نيجاتيف.
نيجاتيف.
خلاص نحطها نيجاتيف. اذا
يعني دائما أسوي نيجاتيف تحت.
اذا تسويها دائما نيجاتيف ما غلط.
بس دائما الإشارة تغير من يعني الإجابة النهائية.
نور ايوه، لكل اتجاه سرعه خاصه. من معي الحين حاليا؟ مريم صح؟ تكلمني. زين. مريم، الاشاره تغير، لكن طالما نحن نستخدم نفس الاشاره اوكي في المساله بكاملها من اول لاخر ما تفرق. زين.
اوكي.
يعني اهم شيء ايش اسوي؟ ما اجي اقول في الجرافيتي وانا نازل جرافيتي از ماينس جي، لكن السرعه تحت بوزيتيف. ما ينفع. اذا انا اقول انه تحت جرافيتي نيجاتيف، لازم السرعه بعد تحت تكون نيجاتيف، الديسبيسمنت بعد تحت يكون نيجاتيف. يعني اذا انا اقول انه هذا صفر زين والاكسلريشن هنا مالي نيجاتيف ماينس جي، معناته انه النقطه اللي هنا ايضا المفروض تكون ماينس 10 مثلا. ما ينفع اجي اقول انه الجرافيتي انه الاكسلريشن ماينس جي لكن الديسبيسمنت بوزيتيف، ما ينفع.
طيب انا قصدي مثلا عندنا في هذه المعادله اللي هي الفيلوسيتي ايكوال يو ماينس جي في التي، اذا اعتبرتها مثلا الجي سالبه انزين، ومره انا يعني اعتبرتها على كيفي بغيتها سالبه، بعدين مره اذا جيت اعتبرتها موجبه يكون الناتج غير، لانه هنا يعني طرح او جمع.
مره وين؟
يعني لو مثلا لو اعتبرتها سالبه الناتج بيكون غير عن لو اعتبرتها موجبه، لانه هنا جمع وطرح
في نفس المساله.
ايوه.
Let me do it. Okay, نور got it. لبنى، المحاضرات وحل أسئلة الكتاب are a very excellent starting point. You know these, you know your labs, you know your tutorials, you are in excellent shape. Okay, Mariam, let's do this. Let's do this with numbers. Maybe it will make it easier.
Okay.
I have an object that I am throwing from 100 meters all the way to ground level, which is 0 meters.
Okay.
And it is under free fall. Okay, so no other accelerations, no other thing. The only acceleration I have here is G. Okay.
Okay.
Now, أنا حددت أنه فوق هنا 100 صح؟
أيوة.
وهنا صفر. معناته أنا نازل what am I doing؟ أطرح ماينس صح؟ جالس أنقص.
أيوة.
بالتالي هنا بحط ماينس لأني أنا حددت أنه وأنا نازل تحت ماينس. الحين أنا راح أحط شيء ثاني هنا بس we'll come back to it in a little bit. Okay. Okay, I'll come back to it. This is the exact same plane problem, okay, or helicopter problem, but I'm using 100 meters because it's an easy number. Okay?
Okay.
Okay. What is the velocity here of the package, which starts at 0? So u equals 0. What is the velocity of it when we come down?
Okay.
V equals u minus gt. Yes?
Yes.
We agreed u is equal to 0, so v equals minus gt because I have agreed that here. Okay?
Okay.
V equals u plus at. I have defined my g to be negative here. Okay, good?
Yeah, yes.
So my velocity is going to be equal to minus 9.81 times the time it takes to get here. صح؟
صح. But why we consider u equal to 0?
1 second. Oh, well, because we dropped it from rest. We're not throwing it.
Okay.
Okay. Now I don't know what time is, so I'm going to calculate my time. Time equals let me write all my equations here. V equals u plus at. V squared equals u squared plus 2as. And S equals ut plus half at squared. Okay, I'm not going to be using the first equation because it's going to take a long time. Choose. Do you want to use the... I'm going to use the second equation, which is actually perfect for this problem. Okay? V squared equals u squared plus 2as. We have decided that a here is gravity and gravity is negative. So far, so good?
Yes.
Okay, so I'm going to rewrite it. V squared equals u squared minus 2gs. صحيح? Where s is the... I'm going to now راح أعوض. U squared is 0 squared minus 2 times 9.81. S is final position minus initial position. صحيح?
صحيح.
What is my final position here?
0.
And what is my initial position?
100.
Sorry. Final position minus plus 100. So far, so good?
Yes.
So 0 squared, I'll get minus 2, 9.81 minus 100. And so my V squared will be equal to 2 times 9.81 times 100, 1962. Okay?
صحيح.
Which means my velocity, this is V squared, which means my velocity here will be equal to square root of this number.
Okay.
So plus or minus 44.3. In which direction are we going? Down. And we have defined down to be what? We have defined down to be negative, صح?
Yes.
So my V is going to be plus or minus 44.3 meters per second. I am rejecting the plus because I have already defined down to be minus. This is my answer.
Okay.
Do we agree on this?
Yes.
Okay, now I'm going to do the exact same problem again. Okay, لكن راح أقلب الآية بالكامل. I'm going to be using the exact same equation. V squared equals U squared plus 2AS. لكن الحين أنا قلبت الآية. So I'll do V squared equals U squared plus 2GS. لأنه now I define G down to be plus, صح?
صح.
V squared U squared. Oh, let me put in the numbers. V squared equals 0 squared plus 2, 9.81. But now, what is S? Final minus initial.
الS بتكون 100.
Minus 100.
Why negative?
Wait, what did I do here? 1 second, I did something wrong. Sorry.
Doctor, I have a question.
Yes.
تو هنا المسافة احنا ما نسوي المسافة اللي هي بين الأرض وبين مستوى الجسم، يعني
أيوة.
ما المسافة اللي قطعها. فالمفترض يعني هنا ما تكون هنا 0. يعني الأس لما نجي نكتب الأس نبغى مثلا نطلع اللي هي الفاينل سبيد اللي هي الV2. لما نعوض عن الأس مثلا إذا كان الجسم في منتصف المسافة ما نعوض عن الأس ب50.
صح.
يعني تكون المسافة بين الجسم وبين مستوى الأرض.
صح. لأنك أنت عرفتيها بهذه الطريقة. ممكن تعرفيها أنه المسافة ما بين الجسم وما بين نقطة بداية الجسم.
متى أعرفها بين يعني بداية يعني في المقذوفات أنا اللي أعرفه بين مستوى الجسم والأرض.
ما في قانون يقول أنه لازم بين المستوى الجسم والأرض. ممكن تحدديه ما بين الجسم والمريخ، ما في إشكالية طالما أنك تلتزمي بهذا في بقية حل المسألة. فاهمة كيف؟
أيوة فاهمة.
أسهل شيء بالنسبة لنا أنه بالعادة نحدده مع مستوى الأرض، ومستوى الأرض يكون صفر.
زين. فهنا في الرسمة الأولى لما سويت تحت اللي هي تساوي 100، طب يعني المسافة هذه 100 هي 100 ماشي خلاص ما انتبه.
هنا أنا حددت أنه هذا صفر.
أيوة.
وهذه 100.
طيب ليش قلنا اللي تحت 100؟ لأن المسافة يعني هو يكون على مستوى الأرض.
لا، لأنه أنا هنا حددت أنه أنا هنا غيرت المسألة، نفس المسألة بس أنا بدل ما آخذ نقطة الارتكاز إنزين إنها تكون الأرض صفر.
أيوة.
طيب أنا أخذت نقطة بداية الحركة هي صفر.
يعني يستوي بس أمسك مثلا قانون أو مثلا أخذ هذه اللي دائما لما يكون دروب أخذ التسارع يكون بالسالب اللي هي الجي بالسالب، وأعتبر المسافة تكون بين مستوى الجسم وبين الأرض.
ما فيها أي إشكالية.
يعني بس أتبع هذه القاعدة عادي، هذه يعني خلي أعرف.
No problem at all.
طيب شكرا.
But the point I am making is أنه if I'm doing this here this way, okay. الحين في المسألة الأولى إذا أنا حطيت هنا صفر هذه لازم تكون سالب 100 because I'm going down I'm doing negative.
أوكي.
في هذه المسألة I'm going down I'm doing positive. فإذا حطيت هذه صفر هذه راح تكون 100. فهنا بتصير 100 سالب صفر والنتيجة بتكون بالضبط نفس قدر. اوكي. هذه هي القاعدة اللي نقول نلزمهم بما ألزموا به أنفسهم. If we say that down is negative, then down has to be negative. Plus 100 going this, or 0 to minus 100. If we say down is positive, then if I say this is 0, this becomes 100. If I say this is 100, this needs to become 200.
200. Okay.
As long as we stick to the convention, أمورنا طيبة.
طيب عندي سؤال ثاني بس ما يخص هذا. لما قبل حنحدد الزاوية تكون في أي ربع في السؤال اللي عطيتنا إياه اليوم. وقلنا إن هي في الربع الأول.
أيوة.
إنزين. كيف أعرف إنه مثلا في هذا السؤال يعني وش هو يعني الكلمة أو السنتنس في السؤال اللي هي يعني تخبرني إنه هذا يعني قصده شابتر 4 ما شابتر 2. يعني أنا كيف أعرف إني أعتمد طريقة اللي هو الكوارد
هم نفسهم. شابتر 4 وشابتر 2 هو نفس الشيء. الفرق الوحيد أنه هو قال ليش what is velocity. في chapter 2 بدل ما يقول ليش what is velocity كان بيسأل ليش what is the direction of the vector. بس.
يعني لما يقول لي direction.
الحل نفس الحل والجواب نفس السؤال نفس الجواب ما يتغير. 5 مازن.
أوكي. يعني لما يقول الفيلوسيتي يقصده هذه الطريقة. لأني لو طبقت يعني الطريقة الماضية
نفس الشيء. أي طريقة ماضية.
قبل يعني مثلا لما هنا نجي نحدد الزاوية عندي بتكون tan -2/2 اللي هي tan 1. فلما أجي أحدد تطلع لي الزاوية بتكون سالب 45. السالب يعني هي عكس عقارب الساعة 45.
So let's see if I do. Okay, I see where your confusion is. What you did is tan -2/2, so -1. Tan inverse of -1 gives you -45 degrees, صح? The question is, where are you defining it from? Is it -45 degrees this way or -45 degrees this way? Where is positive, where is negative? صح?
أيوه.
Do you add 180? Do you not add 180 degrees? Okay, so the key here is whether you're moving clockwise or counterclockwise. The rule is still the same. The key here is, do I move clockwise or counterclockwise? Here, okay, because I am moving clockwise, my correct answer is this one first. Okay, so when I get minus 45 degrees, okay, I go. I define positive to be clockwise with the direction of motion. So minus 45 was going up like this, so it's in the first quadrant. Here, okay, I again got minus 45 degrees, okay, but my direction of motion is counterclockwise, so I needed to add 180 degrees. So I went all the way to the third quadrant.
Okay.
Okay, sometimes it's just easier to draw it.
Okay, I understand.
Perfect. Yeah.
Thank you.
So welcome. Saoud, yes, we will take it actually circle motion is in next lecture. Okay, but this was just for the directions. Okay, صارت الساعة 2. I have to go because I have another thing to attend in about 15 minutes. بعدنا بناخذها قدام. Yes, circular motion is next lecture. Okay, if that is all, I need to leave now. So I will see you, inshallah, on Monday. I will upload everything, inshallah, by the end of today. Okay, well, by tonight, before midnight, inshallah. I'll upload both lectures, the Monday one and today's lecture. And I will also try to publish the mock quiz. Okay? في أمان الله.